Hi guys, so today I will be taking you through the data pre-processing phase of your ML journey, specifically with SQL and OQLIS. So let's start with the formal definition of data pre-processing. Data pre-processing is a technique that involves transforming raw data into an understandable format, as real-world data is often incomplete, inconsistent, lacking in certain behaviors or trends, and is likely to contain many errors. This step is crucial to the performance of your model, as unclean data can negatively impact the model's learning ability and make it harder to generalize the data. So data pre-processing is typically broken up into 4 steps, and for those of you that are fortunate enough to be using OQLIS, steps 2, 3, and 4 are automatically taken care of on the platform. Now, I will be providing a brief description of these steps at the end of the video, but for now, the focus will be on handling missing data. Real-world data is never really complete. There's always some sort of missing value, either null values, empty strings, or false values. So let's jump over to Workbench and have a look at some practical examples. I've created a dataset of a fake soccer team. Each column has got a null value, a false value, and an empty string. So please take note that MySQL does not contain a built-in Boolean data type, and so it displays false values as 0, and non-zero values are read as true. So another thing is that in the numerical columns, empty strings are also 0 because these columns are integer data types and they cannot display standard strings. For large data sets with a low percentage of missing data, we can just delete the rows with missing values, as it won't affect the overall trends and patterns of the data. We can do this with the following delete statements, and since we're only dealing with 4 columns, I've specified the column names manually in these statements. However, if you want to iterate over columns with a large number of columns, I'd recommend doing this with a Python script of sorts. So by running the 3 delete statements, we delete the first 3 columns or first 3 rows of the dataset, and the same can be done for the other columns by changing the column name in the delete statement. But what alternatives are there if you don't want to delete your data? Well, for string columns, there's not much we can do unless we have the actual values stored somewhere else. At most, we can replace it with a standardized unknown value, which is what I've done here. So all of our null values, our empty strings, and our false values in the name column will get replaced with unknown player. For numerical columns, however, we can replace these missing values with a statistic such as average or median. This will fit the general trend of the data much better than 0 or null, and will allow your model to generalize the data and learn more effectively. So if I run these statements here, you can see, once it's done, we can see that our the first 3 columns were replaced with unknown player, and there are no missing values in the height column because they have all been replaced with the average. The same can be done with the skill rating, but I just haven't done it in this example. So these 2 techniques of either deleting or replacing values are the most common and the most foolproof methods of handling missing data. However, they are not the only methods. You can use ML algorithms such as regression to predict missing values, but I strongly advise against doing this unless you really know what you're doing. So let's jump back to the slides quick, and we can discuss the other 3 steps of data pre-processing, which I promised earlier in the video. Bear in mind that OQLIS does these steps automatically, so OQLIS viewers, you don't have to carry on with the video unless you are interested in how these steps work. Encoding categorical variables is essentially converting strings or categories into numbers. For example, imagine we have the following data set with a city column with 3 distinct categories. Now, an ML model cannot effectively understand the difference between these 3 categories, so we need to assign them a unique numerical value. But this comes with a problem. So because these values are numerical, the model may interpret them as having an order. For example, Montreal may be perceived as greater than Vancouver, when actually there is no relationship order between these three cities. So to avoid this problem, each category is turned into its own binary column as shown on screen. This allows the model to make an association between your categories and your target variable without ranking the categories. The next step is creating your training and testing set. This is a relatively simple task. Essentially, it is done so that you can train your model on 80% of the data and then validate its performance on unseen data, which is the remaining 20% of your data set. One thing to keep in mind is that you should make sure your data set is balanced. OQLIS automatically does this for you, but essentially what it means is that you should have equal proportions of each outcome in your training set if you are predicting categorical variables. For example, if you were to predict whether or not a person bought a vehicle, you would need equal amounts of people who bought the vehicle versus people who didn't buy the vehicle in your training set. Now, feature scaling is the last step of our data pre-processing, and essentially what it does, or the reason behind feature scaling, is because if we look at our income and age column, we can see that these values are very different in size. And when we plot these values on the same axes, it causes the age column to be completely dominated by the income column, meaning that age is hardly even visible on our plot. Now, if your model had to interpret this data, it would assume that age has no significance at all to the prediction of your target variable, which may not be the case. So to address this problem, we apply the following formula to standardize the data in both columns. And now we can see that our transformed data is on the same scale, and we can actually see a visual representation of the age column now. This allows your ML model to make much more accurate predictions and prevents one variable from dominating another. So that is all for today, but if you have any questions or recommendations for future videos, please leave a comment below.